Is it okay? Well, if everything is okay, let me go to the next one. P2P. In fact, we already know P2P, and this time we just want to let you know we have one reason, and that reason allows us to use P2P. Well, some explanation here, maybe I may skip. So do you think we have always on P2P? If no, it's pure. But normally, no pure P2P. And arbitrary AND system can communicate with the other AND system. If so, this is the P2P. And because of the arrangement or the feature of a P2P, peers are intermittently connected. That says, I want to connect with you, then I can connect with you. If no, that's okay. So intermittently connected to each other. And may change IP. If yes, want to have some example associated with the pure P2P, we can have BitTorrent, Kankan, and Skype serving as a possible example. But even we have this example, they are still not pure P2P because, for example, Skype, you can think is pure P2P. No, we still have the other type of server to maintain the peers are on or not. So in fact, not pure, but it's hard to find pure. So that's why we got to have 3 examples here. Well, next one, we just want to have some calculation. The calculation here that you feel, if we have all the calculation, we may find the strong reason why we want to use P2P. To find a strong reason, we ask you the question, how much time to distribute file size F from one server to n peers? This is a question. The question allows us to have 2 ways to have the calculation. First of all, we use client-server approach. And second one, we use P2P. And so that we already have the possible time. But for the possible time, we don't have the exact time. Instead, we already have some bound. Okay, we already have some bound for capturing the time. All right, so here actually need to upload and download. So we have upload and download. So we have all the capacity here. Even for the server can upload. So server upload with the capacity. Server download with server actually it is not necessary to download. So we don't have download capacity associated with the server. Well, we have the notations here. Is it okay? And we assume network with abundant bandwidth. Abundant, that says you have enough bandwidth. So it's not the bottleneck. Talking about the network, it's not the bottleneck. But we assume bottleneck perhaps is the server or is the client or the peer. Well, this is a given question. And for the given question, first of all, we need to check by using client-server model. All right, if we have a client-server model, server transmission required. So upload, first of all, should upload, right? And the next one, you are asked to do this. How much time to distribute file from one server to n peers? So if we use client server, we need to upload and then download, right? If we have these First of all, this is a piece. Time to upload. How many times to upload? Because n peers using client server. So nf over mu s, right? So this is first piece. And the second piece, which one serves the bottleneck? Then we choose this. For example, this one and this one. Formally, the time actually should be the sum of the twos. But this time we just want to choose the try to ask you to find the bound. The bound actually try to find the bottleneck. So where you have a bottleneck, maybe the bottleneck is the server. So NF over the uploading rate, the first one, serving as a bottleneck. Or maybe the real bottleneck of the server. So we use this D minimum, the minimum rate, and you can have F over the minimum rate. Actually, you can choose among. Actually, you can choose between, not among. Choose between the two values. Which one is a bottleneck, and then you choose it. And choose it serving as the bound, the lower bound. Time to distribute F to n clients using client-server approach. And we use a bound. And this is the first approach by calculating the bound. About the bound here is okay. Max. Something like find the bottleneck, right? Well, if it is acceptable, we have the bound associated with the client-server approach. And likewise, you can find the bound. And the bound find the bottleneck as well. First of all, you just send one copy if we have a peer-to-peer. So it's F over mu s. So the first piece. And the bottleneck the same. But the next one, NF collaborate by the server and also by the client. So that's why the rate is the aggregate rate, mu s plus O, the uploading rate. And this is collaboration because P2P, in fact, we have the collaboration. All right, so the bottleneck here perhaps is one copy from the server. And after that one, even concluding the first one, we have a first copy and to the nth copy. Put them together, so you have NF collaborated by the server and the peer. So we have the summation of uploading capacity. All right, so we use this way, and which one serves the bottleneck, then we choose it to serve the bound. Up now, we always calculate the bound rather than the exact value. However, we use the bound to illustrate the benefit of client server or peer-to-peer. So we can have the calculation. If that you have the possible value. All right, and this is a bound only. It's a bound. It's a bound only, right? The minimum distribution time. Minimum required distribution time. And we think that's all the time. And if we have the minimum required distribution time for P2P lower than client server, so finally we claim P2P can have actually a bit faster response time for P2P. So finally we choose P2P. And if we have a bit faster response time, what it means? Here we use the term again. Scalability is good for P2P. If we care about the minimum distribution time, you see, even we have many peers, the distribution time can saturate it. However, for client server, no, we always climb up, so we don't have the saturated value for client server. Well, because of the observation based on the minimum distribution time, then we can claim. Talking about this, response time for P2P can be shorter because it is shorter, so it will be scalable. Because of scalable, so we think P2P can provide good scalability. So that's why we recommend you if we want to do something like this. Have a copy from server to peers. If we want to do something like this, which architecture will be better? Not client server. It's P2P. So we just want to use the calculation here, even it is not exact. But it seems to be we can use this to serve as a reference evidence. And the evidence reveals P2P is good. So finally, we recommend P2P for a scenario like this if we want to have the file distribution among peers. Well, even it is not the exact calculation, but something like we may rely on the information. Bottleneck, using bottleneck to find the response time, and based on the bottleneck response time, actually is the minimum distribution time. And use it so we can show the advantage of P2P. And so they will claim P2P, in fact, is good to associate with the file distribution or something similar to a file distribution. All right, that's it. So this is a reason for you to illustrate everything's okay. And before I close, I just use this one. So we have the shorthand VS period rather than VS without period or something else. Okay, draw your attention to this because sometimes if you want to use it, this is a correct one. All right, that's it. So if no question, let's call it a day. Okay, before you go, let me make sure. Any questions? If no, that's it. And see you this Wednesday.